The slide illustrates the traditional concept of a directory structure in a file system. The directory structure is represented at the top of the diagram by a set of nodes. Each node corresponds to a direct entry, which can contain information about a file. For example, the file name. Below the nodes are squares labeled F1, F2, F3, F4 to Fn, representing individual files. Note that F1, F2 through to Fn are human unreadable unique IDs. The lines between the directory nodes and the files indicate the relationship or linkage that the directory has to each file. Hence, the purpose of the directory is to create the relation between the file's name and the unique ID. Both the directory structure and the files are stored on the disk to prevent loss of file content as well as the directory information in the event of a computer shutdown or power outage. Here is a list of common operations that can be performed within a file system's directory structure. These operations are fundamental to file management in operating systems. Here is what each operation typically involves. Search for a file. Locate a file within the directory structure. This can involve searching by file name, file type, or other attributes. Create a file. Makes a new file in a directory. This involves specifying a file name and possibly its type, like .txt and .jpg. Delete a file removes a file from the directory, which often means it also removed from the storage medium. List a directory displays the contents of a directory, including files and subdirectories. Rename a file changes the name of a file. This does not typically affect the contents of the file, just how it's referred to in the directory. Traverse the file system moves through the file system structure, which can include moving into and out of directories to navigate to different files or directories within the system. These operations are essential for the organization, retrieval, and management of files on a computer or storage device.